Good evening, everyone. So my name is Raj. I'm a data architect at Fotenix, designing scalable platforms for multispectral imaging in controlled environment agriculture. So my work spans across cloud native pipelines, designing systems for today's cloud native works that can be in future deployed to edge systems. And today I'll discuss on the Fotenix's instance on emerging role of edge deployments to reduce the latency, improving resilience, and enabling earlier crop stress detection in controlled environment agriculture. So before talking about the technology, I think it's important for us to ground ourselves in why agriculture matters and why the status quo is increasingly risky. So food security is an abstract issue. It's structural, economic, and operational one. In UK, 82% of our fruits and nearly half of our vegetables are imported. So that means our food supply is heavily influenced by geography, operations, logistics, and geopolitics. And fresh produce specifically is quite under influence of degrading. So for example, vitamin C decay of fresh produce alone shows that, the nutritional content of the fresh produce decays significantly, especially in leafy greens. Long supply chains introduces time, temperature, and handling risks before it even reaches the consumers. Majority of fresh produce, most of it can be domestically produced. So why aren't we doing it already? So aging infrastructure is a massive problem. Over 70% of UK's greenhouses are 40 years old. So they are not designed for modern demands, energy efficiency, or the operational efficiency required to mass manufacture in an efficient way. Labor shortage has always been a significant problem. The industry loses over 60 million pounds annually in crop losses just because there's not enough people to manage and harvest producing time. The margins are really small. The increasing energy prices become quite difficult to make profits on. As an example, for a bag of apple that is 220 pounds, our growers only make 3 pence. So that leaves no room for inefficiencies, errors, or late intervention. And this is the context in which Fotenix operates in. We are not just a technology provider. We are an enabler for the domestic produce, and we design and manufacture camera systems that can be easily deployed and up and running within 24 hours, providing valuable insights and actionable intelligence that our growers can capitalize on. So precision control is a big focus for us. Plants already tell us quite a lot on their performance. That can be by seeing the growth patterns, stress signals, and physiology. And this is what we tap on. We use these signals to maintain optimal growing conditions such that our growers can operate more profitably. Resource efficiency is another key focus for us. By understanding exactly when and where the intervention needs to happen, and our growers can reduce inputs in labor, water, energy, and chemicals. And each of these inputs are essentially quite real financial risks. Finally, our systems are fully automated, so they provide year-round resilience. It decouples the growing from seasonal volatility and climate shocks, and therefore the growers can work in more predictable fashion. And this predictability is what makes domestic growing economically defensible. So going back to the talk of today and how our technology works and how we are moving to the edge, it's important to be honest about where we are at now. So Fotenix today is cloud first. A majority of our systems, majority of the processing happens on the cloud. And this has worked very well for us. It gives us the observability, resilience, ability to iterate really quickly and make mistakes, learn from it, and move on quickly. So our devices are essentially Internet of Things devices. They are deployed throughout UK. And these devices take images periodically or via API calls that are integrated with the control systems of the greenhouses. These images are then tagged with accurate and meaningful metadata. So that could be location, where exactly is the image taken, what crops were it looking at, this sort of metadata. They are all packaged and then uploaded to our cloud storage and databases. And the pipelines then pick up this data and processes them to extract meaningful information in the form of metrics, RGB data, heat maps, and aggregation level data. So this architecture obviously gives us, consistency, resilience, and reliability. So why do we need to move to edge? So this all works in cloud until physics, scalability, and cost becomes significant problem. Cost amplification, data explosion, and insight latency, when combined together, it just stops being a question of what scales on the cloud and more on where should the computation live. And what's breaking here isn't the cloud, and cloud works perfectly fine. But what's breaking is the assumption that every byte needs to travel before it becomes useful. And in agriculture, especially in rural bandwidth constrained environment, this delay becomes quite significant. Just to put it into perspective, each of our sites generates hundreds of gigabytes per day. That is equivalent to 25 HDN every day, each site. We have gathered over 100 terabytes of data that is in our cloud storage. And this movement of data creates significant delays in how we operate and when the results are returned to our customers. So then we obviously want to move to the edge, but our stance on moving to edge is not about pushing everything to the edge. There are some good candidates that can be easily leveraged, and there are some processes and things that we want to still keep on the cloud. So things like data quality checks. Is the image good? We can easily check that on the device, and so that it doesn't pollute our data downstream. Segmentation, so picking out leaves and fruits within the image. And this is computationally heavy, don't get me wrong, but it's highly parallelizable and quite deterministic. Data reduction is a massive win. So what we don't want to shape our images, what we really want to shape to cloud are the metrics derived from it. And these are orders of magnitude less than the actual image itself. Event detection, so what changed? What plants are stressed? Did the growth pattern change? Those are pretty crucial to growers, and they can take the feedback loop reduces quite significantly and is therefore quite useful for growers. And obviously inference, once the model is validated well, inference usually takes a lot less computational power and therefore can be deployed to the edge. Some of the bad candidates, heavy model training and cross-site benchmarking doesn't really help as much. It requires a global context and is therefore, probably better left on the cloud and can benefit from the elasticity of the cloud. Long-term trend analysis and heavy analytics, again, we don't need to do it in 2 minutes time. Probably is not a good time frame. We need months or years of data to be able to get those data. So for us, when we talk about edge, it's not about moving models and it's not about new hardwares or fancy new systems, because we already have this in our sites. These are quite our systems that are deployed to each of the sites are equipped with the Jetson, Orens, and the Thor systems. They are quite powerful. Processing headroom is quite significant. They are GPU capable. Currently only being used for imaging, orchestration, or just transfer of data. So that gives us a future-proof system that can be easily leveraged to push things to the edge. So if hardware is not the problem, where is the problem? So for us, the problem is the operational element of it. And so hardware by default is unreliable. And when I say hardware, it's not the electronics, it's the marriage between the electronics and the operating systems. Networks, we operate in rural environments, so the networks is intermittent and asymmetric, which makes observability on the edge quite difficult. It's a lot harder to observe things on the edge. We don't have a AWS dashboard or easily accessible logs that we can just tap into. You need to build an entire infrastructure in place so that this can be easily viewable. And of course, fleet-wide updates are non-trivial. So when we are operating at a scale of hundreds of devices, we can't think of them as single device. We need to think of them as plates, and we need to have systems in place that can roll back, roll out the software quickly without using a lot of human resources. So this is where we are actually, Fotenix is putting significant amount of time and making sure that all these capabilities are there before we really start pushing things to edge. So we are taking a serious stance on lightweight runtime. So we start with very simple base image that can be 90 megabytes or something, and then critically analyze each and every components, libraries that goes into it, essentially reducing the blast radius and friction created by each of the libraries. Each of the libraries, not just operationally, but also security vulnerabilities become quite a significant challenge to update. So we are taking quite a lot of time to understand what is really necessary to move and have those base images very much controlled and very much tight. Observability, of course, if we move to edge, we need the observability. So we are not reinventing wheel here. We are trying to use systems that are already there, but being custom multispectral systems, we obviously need some of those elements, custom elements to it. And this includes things like, why is the camera down? Why is the network down? Why is the system here operating properly? What are the hardware challenges? Each and every aspect of it, we need to be able to nurture and have it at hand and alerting us so that we know it, and with quick turnaround time so that we can maintain our service level agreements. If we bypass this, and the errors go unnoticed, and those are the worst kinds essentially. And of course, the remote fleet optimizations, thinking of devices as fleets, not just single devices. And this is where we are at. The combination of these three pillars is what I think enables us to deploy when the systems are in place. We can easily deploy modules and things, which we already do it on the cloud, just passing it onto the things, because hardware obviously is not a problem for us. I want to close with this idea. So edge is a consequence of maturity, is the stance that we are taking. When we talk about edge, it's normally a technological decision, a decision that when can we deploy, when do we deploy? But in practice, it is a consequence. It is what becomes possible when the data systems and operations can all mature. And it is very critical in the sector that we operate, because the feedback loop and the timings matter. Quicker the turnaround time of the analytics, quicker our growers can intervene and therefore save them valuable and increase their margins essentially. And at Fotenix, that is the focus today. We are essentially we are not rushing to push everything to the edge. We are building the data infrastructure, making sure that when we are ready for deployment, it doesn't become a blind ball problem. This is the idea that I want to close with. If edge feels risky, it is probably because the system is not mature enough. When it is, and I think it's not a decision at that point, it's just a natural next step. Thank you.